Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating comparison. Ada versus Rust, focusing on memory safety. It's a battle of the titans, really.
A classic. I've always been curious about how these two languages stack up. So what's the bottom line? Which one wins the memory safety crown?
Well, it's not quite a clear-cut victory. The article argues that Rust excels at preventing common memory errors at compile time, thanks to its borrow checker. But Ada, with its avoidance of dynamic memory allocation and support for formal verification using Spark, takes a different approach, often avoiding many problems altogether.
Interesting. So Rust is more proactive while Ada is more preventative? Like a fire extinguisher versus fireproofing a building?
Exactly. Rust aggressively stops you from making mistakes, while Ada's design makes many of those mistakes impossible in the first place. The article goes through several common memory errors: memory leaks, buffer overflows, use after free, double freeze, race conditions, dangling pointers, and freeing stacked memory, and compares how each language handles them.
Let's talk about buffer overflows. Both languages have runtime bounds checking, right?
Yes, but the approach differs slightly. In Rust, an out-of-bounds access causes a panic. In Ada, it raises a constraint_error exception, which you can handle. And then there's SPRK, a subset of Ada, where you can formally verify the absence of these errors.
Formal verification? That sounds incredibly powerful, but also, complex.
It is! Spark, used with tools like gnatprove, allows you to mathematically prove the correctness of your code. The article shows an example where SPRK correctly identifies a potential buffer overflow and suggests how to fix it by adding input validation.
That's impressive. What about use after free errors? Rust's borrow checker seems like a big advantage there.
Absolutely. Rust prevents use after free at compile time. Ada, on the other hand, relies on runtime checks. Freeing an access type sets it to null, so any subsequent dereference raises a constraint_error. But you can disable these checks, which then opens the door to undefined behavior, just like in C.
So Ada's safety net is less robust in that case? I see.
Precisely. However, Ada's strength lies in its ability to avoid many of these issues altogether, by minimizing the use of dynamic memory allocation and pointers. The article highlights that most Ada programming guides actually recommend avoiding pointers whenever possible.
That's a significant difference in philosophy. Rust embraces dynamic memory management but controls it rigorously, while Ada tries to avoid it as much as possible.
Exactly. And this difference extends to concurrency. Rust uses mutexes and channels for thread synchronization, while Ada provides protected objects. Both prevent race conditions. But again, Ada's approach is more about preventing the problem from arising in the first place.
The article also mentions dangling pointers. Rust's borrow checker seems to make those impossible in safe code, right?
Correct. The article struggled to even create a dangling pointer in safe Rust. Ada uses accessibility levels to control pointer lifetimes, preventing dangling pointers. However, you can bypass these with unchecked _access, which, again, introduces the potential for undefined behavior.
So it seems like a trade-off. Rust offers strong compile time guarantees, but Ada provides a different kind of safety through its design and formal verification capabilities.
Precisely. The article concludes that both languages have their strengths. Rust is more modern and proactive, while Ada's mature design and formal verification capabilities offer a different path to safety. It's not about which one is better, but rather which one is better suited for a particular task and risk tolerance.
A nuanced perspective. Thanks for breaking it down. It's clear that both languages have a lot to offer, and their differences reflect different approaches to software development.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.